All right, we're back. And it's COMP228, week 13, second last week of semester. Lesson 13, part 4 of our broadcast, and is it part 4? Part 3 of our broadcast. It's incorrect. I'll have to change this after. And what we're doing is we're going to look at where we left off. So let's just get into our little game, which is going to be lesson 13. Right now, lesson 13, if you remember where I left off, yeah, lesson 13, I had a program file like this for our runnable. Right now, you guys who missed it from this morning, boo-hoo to you, right? At least I didn't say poo-poo to the who's, right? All right, so here we go. So if you notice our runnables, if I run this thing, my program, I get my list, and it's interleaving my runnables, which are threads, custom threads that I've made, with my main process. That's all it's doing, right? But there is no rhyme or reason. And we talked about things being atomic, right? And I want to try and talk about that term, because next week we're going to talk about what you're going to be tested on. And remember, you're going to be tested on the stuff we've covered since last test, which is namely, let's go back into the multi-threading piece here. Java FX, you'll have a little bit of a written test on Java FX. You'll have a written piece on JDBC, right? So you have to know JDBC. We're going to ask you questions about CRUD, right? That's part of it, right? And there's also going to be a piece around multi-threading, just from a written perspective. Okay, so a little bit of a test, multiple choice, true, false. That's going to be worth about 5% of your final mark. Okay, again, not a lot of marks. Okay, for another 10% of your final mark, there's going to be your practical, right? Which you're going to have to do some kind of JDBC, right? I'm probably not going to include too much Java effects. If anything, maybe what I'll do is I'll create a UI that's ready for you, and where you have to modify. But nothing that's too much into Java effects, because we really haven't have a lot of chance to do much. You have an assignment that's due. I've been asked to postpone it until Sunday, which I'm okay doing, right? So that way it gives you a little bit more time to take care of the assignment. I know it's hard. It's a hard assignment. It's people aren't used to doing it, so a couple days might help. Although I think it might hurt you too, right? Because you know what I do, right? When I give you a couple days, you still start the day before, right? So it just doesn't matter how many days I give you. That's the way traditionally it works. But let's talk about this idea of stuff being atomic. And if I go back to the book, they actually have some good examples of this, because it's important for us to make a distinction between what's atomic and what's not. So here's what's the definition. I'm going to talk about this in the exam. So an atomic operation cannot be divided into smaller sub-operations. It's an atom, like the atom can't be split kind of idea, although that's not really true in real life. But it's the analogy. The analogy is that you have, something that's atomic that can't be split up, okay? But that's not true when it comes to threading. And what do I mean by that? I mean that the stuff we've written right now is not thread safe, okay? So if I was to look at the stuff we've written, notice how we have our for loop, right? And you would think that this for loop is going to run and that it's atomic, right? That this little thing right here, this little piece right here, this little code, is something that's going to run. It's going to keep running until it's done. Not so in threading. We just saw it was interleaving, right? The ability for us to interleave between different threads, different pieces of our process, right, proves that it's not atomic, which means, right, that we have a problem. So how could you say this? How could you see this might be a problem? Let's look at our runnable for a second. Here's our custom runnable class that we made, right? Remember, we implement the runnable interface. Just a review from this morning, right? In there, we're passing along the name of the runnable. We made this up, right? And we have something called the run method that's been overwritten. That's the one method that we have to override when we implement our runnable interface, right? We have a task that we're going to do. We can have several tasks that are in here. Okay, so question is this task atomic? I want to do this task, right? Is it atomic? And the answer is no. This is not a thread-safe operation we're doing, which means that, you know, while I'm sleeping, while I was sleeping, the thieves came in and stole my money, right? That's what happened, right? I'm just giving you this example. I'm trying to be funny, but the idea is, while this task is sleeping, other things can happen in the background. And because of that, right, my task itself will be broken up into smaller subtasks. That's not good. And why would that not be good? Think about this. What if I have two tasks and they're influencing a single array list object? An example of that would be, I want to add a member to the array list. But another task is removing a member from the array list, or counting and removing. It could end up being an endless loop, right? Especially if it's affecting one while loop. So two tasks affecting one while loop. One's adding to it, the other one's subtracting from it, as an example. Or one for loop where it's changing the index, right? It's changing the values of the index, where it's one's adding to it, the other one's removing from it, until, you know, it's just endless. It'll crash our system. That can happen, and we don't want that to happen. We want our tasks to be atomic, so to speak, right? So that they're encapsulated, they're contained. And the way to do that, of course, is with the synchronized keyword, which I was trying to show you earlier today, right? So if you look here, here's an example of a simple array that they've given us, right? And what we're doing here is we want this array to be atomic, and the way to add that in is, first of all, the method's got to be public. And notice how it says this one is returning a string, but you need to use the synchronized keyword in order for us to, you know, to create that atomic operation, if you will. So let's do that. Let's go in here and see what it does for us, right? So right before the void, we say synchronized. I believe it's with a Z, I can't remember, yes. And when we do this now, let's run it and see what this synchronized keyword does for us. Does it still interleave like the way this does here, right? Remember, we're also using a scheduling manager, a scheduler, right? So in our program.java file, our driver, we're using something called an executor service, or an executor service is actually the way it's supposed to be. The executor service, what it does, right now we've created a fixed thread pool where with a maximum thread count of 3. So I can only have 3 threads in our process that I can grab from to use, right? In the book, it actually uses a new cached thread pool, which I don't have to specify how many threads, right? But in our case, we're using up to 3, all right? So it's going to do that. It's going to execute with the execute keyword. It's going to execute each of the runnables, each of our threads, right? And our main operation. Here's our main operation that's going on right here. It's going to do this too. So let's see how it works. So I press play now, and let's see what it does. Okay, so I got my runnable 0, 0, and then 0, 1, and then 1, 1, and then 2, and then 3, and then 4, 5. Damn, it looks exactly the same. Here's something else, right? I'm done, but I'm not done. Look how I'm kind of still hanging out here. How come? Why isn't this terminating? My operation is still going. Well, there's a piece missing, right? Whenever I have my executor service running, after I've done my operations, right, I need to stop it. So how do I do that? I got to go down to the bottom before inside my main, right? And I got to basically hit my executor. And if I do things properly, notice that there's a shutdown method, right? I got to call the shutdown method. The shutdown method shuts down my executor service, right? So it stops executing. Even though my runnable's done, it's going to keep running, right? Let's try this out. So see this now. I'm going to run this thing. Now again, each operation is going to be doing, it's going to still do its thing, right? Still no difference in terms of how it's being done. Now it's supposed to be when it gets to the end, it shuts down, right? Because now there's nothing that's done anymore. So you need, whenever you have a scheduler like this, right, you need to have some kind of execute method as well as a shutdown method, because this kind of controls when each of the runnables gets called and when it's shut down. Okay? Questions so far? Again, think about the executor method as a controller, that controls which threads are executed, right? Yeah.
I think the version on your GitHub is the older version.
Yes, I will update it. So I'll update that. I'll go to team and I'll go to commit. We'll say something like this. We added a new runnable. So added custom runnable class. Right, that does that, and commit and push. Okay, there we go. So you've got the latest version now. All right, so that's what this piece does. Let's go back to the PowerPoint for a second, so we can take a look. Right. All right. In the book, they have a something that they have this whole idea of this producer-consumer relationship without synchronization idea, right? And it's a pattern. It's a design pattern for creating a thread-safe application, right? And what they do is they have a couple of different methods that they've defined. They've created an interface called buffer, and they've created two methods for the interface that are abstract methods. Pretty much you have to override. One is called blocking put and a blocking get, right? They both potentially throw interrupted exception errors, all right? And what they do in here is they implement both the runnable interface, right, as well as they declare a shared location of type buffer, which is interesting. They're using buffer, right, as a data type, so even though it's an interface, remember you can use the interface as a data type as well to define a potential custom class, if you will, right? And it's really, interfaces are also this contract that we make to ensure that we include certain methods in our files, right? To create almost like the shape of our class, right? We can shape out our class a little bit more with interfaces than we normally would on our own. Also, notice that it has this shared location blocking put count, that it takes a count, right? So it sets the value in the buffer. But nowhere did I declare my buffer, except for here, look, private final buffer of type, and we've just called it shared location. There it is. And this is just a reference to the shared object, right? This is our interface, right? And when I say final, what does final mean? What's final mean in Java? Constant. So that way we can't change this information. Can't change it. It's a shared. This shared location is what we're going to be using. So again, if I was going to look at this, you guys get the latest version? Is it still there? So that's what this example uses. I'm not going to go through it, but this example, producer-consumer idea, is an advanced example, right? It's quite advanced, right? How do I use this, producer-consumer relationship kind of stuff within my code? And what it does is it sends signals from one type to the other. Guys, this is what I was telling you before, and girls. Threading, multi-threading in general, is a complex, advanced topic. In order for you to understand it, you have to try it out, right? So comes the lab that we talked about, right? I want you to create, well, this is where, who knows what the Fibonacci sequence is? Yay, most of you should know what that is, right? Okay. And it's a bit of a coding thing. You can find the Fibonacci sequence online, all right? I want you to do what we just did, all right? I want you to use our code, the code we just have here. We made a custom runnable, right? But what I want to do is, and this is for the remainder of the class today. It's not a test. I'm going to go around and help you guys out. It's a lab where you get a bonus, whether you get it or not. You get a bonus mark, 2.5%. And I'm going to create a little Dropbox for you guys to submit, right? I want to make it so that you get input from the keyboard to tell me how many numbers you want for your Fibonacci sequence, right? Let me look at the Fibonacci sequence for people who don't know what that is, right? And it's actually a very classic exercise both in math as well as in computers, right? There's different ways to do this, right? So if I go Fibonacci sequence, what is the Fibonacci sequence, right? Well, it actually occurs naturally. It occurs in nature, and it starts off, the two numbers that it starts off with is 0 and 1. Now remember, it's a sequence of numbers, right? So what it does is this. It takes the first number, right, and adds it to the second number to produce the third number, right? So if I take 0 and 1, I get 1, and that's the third number. If I take 1 and 1, I get 2, and that's the next number. If I get 2 and 1, I get 3, and that's the next number. 3 and 2 is 5, 5 and 3 is 8, 8 and 5 is 13, 13 and 8 is 21, and so on, all the way up to infinity, right? So this sequence is almost creates a exponential kind of increase, more than an exponential increase in number. It's quite a bit of a wave, and it creates almost like this, kind of different structures in science and in math. So here's, if I look at Fibonacci sequence in Fibonacci number in math, this is the formula. Fn is equal to Fn minus 1 plus Fn minus 2. This is what you need to put into your return statement if you're creating some kind of function, right? Now math is just math, all right? There's some really cool examples online on how you can use this in Java, and I'm going to allow you to use it. So I don't expect you to code this on your own. What I want you to do is grab, and by the way, there's two versions. There's one that's the version, there's the one version, which is the long way to do it. What's the long way to do it? With loops, right? What's the short way to do it? Where's Tyler? You know what I mean? Is he hiding somewhere? He's hiding. Tyler. Tyler.
Wake up, Tyler.
What's the quick way to do Fibonacci sequence in computers, buddy? Right? Quick way to do Fibonacci sequence in code. I mean, what's the quick way to do a Fibonacci calculator? Come on, break your brains on this one.
Import library.
Recursion, right? Who knows what recursion is? Calling a method from itself, within itself, which is kind of a weird thing. It can break the computer. You know, like, you know, the thing that can break the internet, this can break the computer. Be careful, right? When you use recursion, it definitely, what it does is it creates anonymous mirror copies of its own, of the method over and over again, right? So there's two possibilities up here. One of them is, you know, this idea of you can do it with looping. So if you don't understand it, use the loop method, right? And what you're doing there is swapping the loop. You have your temporary variable is equal to number 1. This is inside the loop, right? And then your number 1 is equal to number 2. And then your number 2 is equal to your temporary variable, right? That's how it goes. And what you're doing is you're swapping the numbers around, right? And you're adding the two numbers together over and over again to produce your sequence, right? Where the minimum number is, if the number that you're getting is 0 or 1, then you're returning the number that comes in, right? So a good example of this is if I was going to look at Fibonacci Java example, right? Now the one that you're going to see a lot is recursion, right? So this is a recursive example. And let's take a look at this thing, right? Here's what it would look like, right? But the recursive example up here is it would do this. If n is equal to 0, then return 0. And if n is equal to 1, return 1, right? Otherwise, return Fibonacci, the same method itself, where you pass in the number -1 plus the number -2. You're calling the Fibonacci sequence twice, right? Yes. This is actually quite more efficient than iteration. Yeah, in this particular case, because of the way it's a sequence. Sequences are perfect for recursion, right? Now, and same thing with Tower of Hanoi and all that kind of weird stuff. There's all kinds of other ways of doing it where you can use recursion. And this is an algorithm, right, that you can use which calls itself. And if you think about it, if I pass, let's use this little piece of code here, and let's pass in the number 3, right? So if I pass the number 3, 3 comes in, it's not 0, it's not 1, so it goes here, and it says, okay, 3 minus 1 is 2. So this sequence fires on its own, in its own thread. That's why we're doing this today, right, to see what happens. And this one, Fibonacci n minus 2, 3 minus 2 is 1, right? So let's do this one. This is simple. 3 minus 2 is 1, which returns 1. So this kind of resolves to 1. So I got 1 plus 1, right? Fibonacci 3 minus 1 is 2, goes back into another sequence. It's not 0 or 1, so 2 gets passed into here, plus 2 minus 2, which is 0. So this is 0. So 2 minus 1 is actually equal to 1. When it comes in here, it's just 1. So 1 comes back up the chain to 2. So 2 is actually equal to 1 plus 1, which is 3, right? And that's what 3 is. So you see, that's what it does. It kind of creates copies of itself over and over again. And that's why for some people, we haven't done recursion. I'm not sure. Did you guys cover recursion here at all? And you wouldn't, right? Because it's an advanced topic, right? But since we're on advanced topics and we're doing threading, what the hell, right? Might as well touch recursion too, right? I'm not going to test you on recursion on the exam, all right? I just want you to know that if you see it as an example online, right, that this is what it does. It's calling a method from within itself, right? It can be very dangerous because if you don't do it right and if it doesn't resolve, think about it, iterates. It's just like creating a loop. The loop somehow has to end. When you create a recursive algorithm like this, take a look how it ends. If n is equal to 0, if n is equal to 1, right? It's going to return 0 or 1 in this particular case. That's good, right? Because if it's 0 or 1, it's going to stop kind of being recursive, right? This is the recursion line right here. We want to stop it with one of these two things. If you don't have stops like this, breaks, if you will, right? It will recur, or we keep going down into the rabbit hole forever and break your machine. Endless loop. Don't do it, right? Especially if it's a complex algorithm. It'll keep going and going and going. I'm not saying, I'm being facetious when I say break your machine. It's just going to cause a memory error at the end of the day. It's going to eat all your memory, right? And it's going to crap out. Your actual application will stop running after a while, right? But you never want to. You want to use recursion where it makes sense. This can be considered something of an elegant algorithm, as opposed to the way it looks with loops. Let's take a look at the looping example as just a difference. So Fibonacci Java example with loops. We'll say loops, right? So we don't want. This is what it looks like here. Here's the loop example, right? Much larger, right? And how does this work? It says, well, here's my Fibonacci sequence. Here's my number 1 and my number 2. They've set their minimums to 1 here. That's what they've done here. And what they're doing is returning number 1 and number 2 as the minimum. And then what they're doing is they're swapping this around right here. Like I said, temp is equal to num1, num1 is equal to num2, and then num2 is equal to temp plus num2. And then you get that swapping around happening here in a for loop, as opposed to doing it within a recursive method, right? But you get all this other crap in here too. Right? You don't need, if you use recursion, you don't need any of that, right? Well, you need some of it, but not all this. So I'm going to leave it to you. Pull down an algorithm from the web. It's going to be covering Fibonacci, all right? You can write one on your own if you like to, if you want to try it out, right? I want you to take it, and where we have our little example up online on GitHub, right, with my driver class and my runnable, I want you to use this pattern that we've established, right, where you create a runnable. Right? Here's our runnable right here. Right? You can even leave it the way it is. Inside the task that I'm running here, this is the task. This is where you're going to put the recursive method right in here, right? And I want somewhere this is the one piece you're going to have to write till the end of day, right? You've got about, what is it, an hour and a half to do this properly for 2.5%. And I'll come around to help you, like I said, and it's bonus. So you're not going to lose, right, if you do this with me, right? I want you to pull the interface. So pull, get a scanner from the console to get user input, right? To say how big of a number do you want? 5, 6, whatever it's going to be. But run the Fibonacci sequence in a thread. All right, run it in its own thread, and I want you to see what you get. Okay. Questions around this? Let's outline it on Dropbox so you guys have a very clear idea of what's going to be done, right? So I know people are going to have like, what is he talking about? He's killing us with our stuff, right? We don't want that to happen, so let's go. I kind of see this as free marks myself, so it's just, just about you guys being here and trying it out. And then you've kind of did a little bit of an example around multi-threading, but it's not going to kill you. It's not meant to kill you. This is only scratching the surface stuff again, right? But it's enough intro so you understand a couple things. Here's a bonus. If you do the recursive piece, it's good learning for you, right? It's good learning to just pull down recursive. Yes. Oh, you want to try your own recursive? You can make your own, right? You don't have to use one of these algorithms. You can make your own algorithm to solve the Fibonacci sequence if you like to. That's up to you. It's a little challenge for you guys, right? Okay, so here in Dropbox, I'm going to make this new lab. I'm going to call this lab 2. All right, so let's just try this out. So new folder. We're going to call this lab 2, right? In lab 2, it's going to be worth 2.5%, right? And I'm going to make a new grade item, right, which is also going to be called lab 2. And in lab 2, we're going to make it so that the grade item, which is worth 2.5%, is going to be bonus. So it means you do it, it's not going to hurt you. You don't do it, it's not going to hurt you, right? Either way, nothing hurts, right? Save. So now what about the instructions? So using the example code on GitHub, and then remember the example code on GitHub, where was it? And we'll get it from GitHub. Those people who missed in the morning class, I'll show you where that is. And if we'll go look at Centennial College, lesson 13, this is the link. Let's pull this link in into the actual thing to make it nice and easy for you. So even if you don't know where it is, it'll be here, right? There it is. And some code from the web, your choice, okay? Create a simple application that asks the user how many numbers to display in the Fibonacci sequence. Fibonacci sequence. Right? Application will display the numbers. Well, actually, the application will use the runnable custom runnable class to contain the Fibonacci algorithm. Spell like that, yeah? Clear? More details? Should I frame that different? Aaron, would you write it differently?
More spaces.
Jesus.
There we go, let's go.
Okay, a simple application that asks the user how many numbers to display in the Fibonacci sequence. So Fibonacci sequence, application will use a custom runnable class to contain the Fibonacci algorithm, right? Ensure you use appropriate user validation techniques. Put in there, what is it called? Exception handling. I'll be okay today. This is a bonus lab worth 2.5%. Okay, due date tonight, right? So it's got to be done. You have time to do it in class right now, and it's due tonight. We'll make it due by midnight. Okay, for those people, even if you can't finish it in class, you can go home and do it, right? So that way I don't kill you guys with this thing. If you really want to leave early, you can do that, right? But it's due tonight for the bonus, which is December the 8th at midnight. And maybe I should probably categorize it. Eh? How about that? Categorize it as a lab. There we go. One more thing. Lab 2, we'll call this Fibonacci thread. The Fibonacci thread. It almost be a book. Fibonacci thread. And let me know if you need help. I'll be coming around. Okay, that's it for me. For next week, one thing more. As you guys start to work on this thing on your own, I'll talk to get this done. Remember that what we covered was we covered those three topics, right? So we copied a little bit of multi-threading, We just copied it now. Very, very simple, high level. I don't expect you to know every piece of everything in the PowerPoint presentation. You can use the PowerPoint presentation for some pieces anyway. It's going to be open book, right? So it's not going to be a big issue for you, right? You need to know about JDBC. You'll have access to look at your code when you answer the questions about JDBC and all that kind of stuff, and your PowerPoint presentations. So when we talk about things like how to perform CRUD, I will be putting questions in there about MySQL, right? Because we're using MySQL database, right? Very high level again. How to use phpMyAdmin, that kind of stuff to create a database. How to how do you create a user? Some stuff like that we covered in the videos, right? I may ask you to create your own database or add in your own stuff in MySQL, right? I may not, right? And the reason why I'm saying I may or may not, because the problem with it is some people don't have their practical piece. They don't have their machine ready. Doesn't function, whatever. Who still doesn't have MAMP or WAMP or ZAMP running? Anybody? Okay, I know you. Get out of here. Right? I'm talking about like people who can't make it. Get out of here. Jason, you know how to make it work though? Come on. You don't have it either? What's wrong with you? Aaron, help them out. Right? Help these two guys out. They need help.
Let me install one.
All right, so we'll see how it works from that. Like, we still need some way of connecting to a database, so we got to figure out how to do that without you guys getting blocked by by the networking cops, right? If I put a database somewhere up on the web somewhere, you're probably blocked, right?
Change it to 421.
I don't know. We'll see, right? Maybe I'll put it up on Azure somewhere, and you guys can access the same database. Just connect to it, right? But either way, I will test it before the day comes next week from here. So I know if I can access it, you should be able to access it, right? And that's really in a nutshell. So 5% for written, 10% for practical. The practical piece will need some kind of database, and you'll probably have to have some kind of UI that you have to use. I won't ask you to make a UI too much, probably because there's no time. So there's no time for a UI. You have to use it. I'll probably create it, and you'll use it, and you have to spit it out in the UI. But I won't ask you to physically design it. You may have to connect it, right? That's about it, right? So it's going to be more. It's more, again, the practical piece is always easier than the multiple choice. Oh, sorry, more is harder than the multiple choice. So there's not really much you can do to prepare other than if either you know your stuff or not. You'll have access to all your code, all the code that I've given to you, all your assignments. So it's not like you'll be limited to what you have. So you should be able to complete it without a hitch. Questions before I sign off? Okay. Remember, this is a lab and it's a bonus. There's nothing that's going to stop you from working with somebody else, all right, to get it done. Okay, so please do that. This is a learning thing. It's not meant for stress. It's meant for relaxation. Okay, so please go ahead and do what you have to do.